This is the video on Do a Gray Code Search. Here on the left is the routine that does a gray code search. Over here on the right are parts of lists needed for the gray code search. This first box has the first 20 values from the list called offsets. It tells it which particular bit is supposed to be either brought into the solution or taken out of the solution. 20 means the first bit is to be brought into the solution. 40, the second one. Notice they're 20 apart, and it'll continue that way. So 40 is the second. It's going to be brought into the solution when it's a 40. 10, 20 means the first bit is going to be taken out of the solution. Next it says 60. That means the third bit is being brought into the solution. Next we see a 20 again, meaning the first one's being brought into the solution again. Then we see 1040, meaning the second one is being taken out of the solution. This is the way the gray code works. One item is either being put in or taken out, but it's such that it's put in, then it's taken out, it's put in, then it's taken out. This is the offsets list, which has the gray code in it. The rest of this data is all from the gray data list. All of these offsets are offsets in gray data. 20 here means for the first bit, the requirements are 4 and 3. The reason they're 20 apart between the first bit and the second bit is because there could be up to 20 requirements for the bit. But this one only has 2 requirements, 4 of this part and 3 of this part. And at offset 40 would be for the second bit, but that bit is actually for this one being twice. So it's 8 and 6. Notice they're minuses because it's coming into the solution, therefore it's being subtracted out from what is left. Below that we have 1020, which is the first bit being taken out of the solution. So when it's taken out of the solution, it puts back the requirements of 4 and 3, and when it was doubled, because we know now that the second bit was really just the first bit twice, so it's 8 and 6. After that, we have whether it's a profit or a price. Here it says if the first one is brought in, the price will be increased by 5. Over here it calls it the current income. The second item, if it's brought into the solution, the current income will be increased by 10. And the box below it is for when they're taken out of the solution. The current income will be lowered by 5, and for the second bit, it will be lowered by 10. Now the next offsets are for whether the item is in the solution or not. That is, if the first bit is in the solution, this value is set to 1. When the second item is put in the solution, this is set to 1. And then there will be one of these for every bit. There will also be at 5020 a -1 because then it's taken back out. And for this one, there will be a -1 for the second bit. Now we're going to start going over the routine. First it sets NS, that's a control register, to 18. It needs to know down here where there's add list, to the gray left, add the gray data plus J with the gray left. And here, another add list where it's going to add gray data at 4000 plus J to the test list to give the new test list. But let's continue. That's what NS is being set to 18 for. Then it fills the 18 values at test list with 0, meaning none of the bits are in the solution. The next one moves the 8 values at tray left to gray left. There could be some parts already used and subtracted from what's on hand, and then that's what's put in the tray left. So there may be already requirements taken away from the on-hand list. So the tray left was made, that's how many are still left. That's now put into the gray left, how many we can use now in the search. Also sets the current income to the tray income, because if some of the requirements were already had, some income was made from their being taken. Then we go into the loop for I of 1 to down here, next I trials one at a time. We're going to go through here for every trial. The first thing that it does is it sets J equal to the value at offsets plus I. Well, offsets plus 1 is this 20, and we know that that means the first bit is going to be brought into the solution. That's the first thing it's going to do. Well, it first adds to the to the current income, what's at grade data list 2000 plus J. Well, we know that's these two down here. At 2020, it would add 5, because that's the value of having the first bit in the solution. Then it says an add L, where the grade data plus J is going to be added to the gray list. Well, over here, we're at 20. It's going to be the first item. It's going to subtract 4 of this part and 3 of this part. Those are the requirements for that first item. Well, in this case, we call it the first bit, which is also the first item. All right, so there it's subtracting them from what's left if it's a 20, but later on it's going to be 1020. Then it's going to come down here because it's actually taking that bit out of the solution, so it adds them back, adds the 4 back and the 1 back. If it's the second bit, it adds the 8 back and the 6 back. The next line, it does also an add list, where it says the grade data at 4000 plus J is being added to the test list. Well, down here at 4000, we know that it's going to add a 1 if it's going into the solution, that is the first bit. If the second bit is going to go into the solution, it's going to add a 1 to the second position. This is how it's keeping track of which bits are in the solution or out of the solution. That's in the test list here. Then it says branch if less than or equal, the current income is less than or equal to the best income. Well, that means the one we just did is no better than one we have already. So it's going to go here to CE, which is down here. Then it will go to the next trial. However, if it is better, it's going to check to see if any of the parts left is less than 0. So here for k of 0 to 7, there's 8 parts. It's going to go around here 8 times, 0 to 7. And each time it's going to check this gray list here. Remember, that's where we subtracted the requirements, like the 4 and the 3 up here. If that goes negative, well then this might be a better solution income-wise, but it's not a valid solution because the left for a particular one of the parts went below 0. So right away it goes down to CE. It can't consider this solution. However, if not only is this a better profit-wise solution, but it also satisfies all the requirements, then we say the best income is this current income, and we save the information at this particular time. We save the gray left in hold list. We save in the best list the test list. That's so at the end, the best list will contain a 1 for every bit that's in the solution and a 0 for which are not. So we can get the quantities from that. And here it moves the 10 values in the best list at offset 18, the tray list. That is the bits that were set on previously before we ever started. Remember up here we had the tray left is what is gray left, and the tray income was the starting value for the current income. So this is what happens if it finds a better solution. It saves the best of the solutions. Well, and here we know it goes around here the trial number of times. Alright, that's the end of the video on do a gray code search.